All right, so I think I'm recording. Let's take a look at this problem. It's a uniform motion problem. Howard and Phil start from 2 points, which are 375 miles apart, and travel toward each other. The later travels twice as fast as the former. They meet in 5 hours. Find the rates per hour. So let's make a sketch here. Let's over here have Howard's starting position. And over here to the right, let's have Phil. Now, what do we know? Um, let's look at this. The later travels twice as fast. The later is Phil, so Phil is traveling faster. So to avoid a fraction, what if I let Howard's rate be x? And that's in miles per hour. And it says the later travels twice as fast. The later is Phil, so Phil's rate is twice as fast as Howard's rate. So if Howard is traveling x miles per hour, then Phil is traveling 2x miles per hour. That should do it. The length of time that Howard is on the road is 5 hours. And that's the same length of time that Phil is on the road. Now, since Phil is traveling faster, he has traveled a further distance. It's telling us that the total distance between them is 375 miles. So let's split that up into the number of miles that Phil has traveled and the number of miles that Howard has traveled. So if we let x be the distance that Howard has traveled, then that means that Phil has traveled the remainder of that 375 miles. Because together, their distances have to add up to 375. Oop, I forgot my minus x. All right, and this is in miles, and this is in miles. So we know our relationship is distance is equal to rate times time. Now, what I would do is say the total distance is the distance that Howard traveled plus the distance that Phil traveled because there's no overlap. I can do that because there's no overlap. Because if I go rate times time and rate times time, those distances aren't the same. But they have travel. I can look at it that time is distance divided by rate, but I don't know the distance and I don't know the rate, so that would be 2 unknown. So yeah, this is how I believe how we should approach this, that the total distance can be split up into the distance that Howard traveled plus the distance that Phil traveled, because it gives us the total distance between the two as being 375. Now, distance is rate times time. So the distance that Howard traveled is the rate that Howard is traveling times the length of time that Howard traveled. And the distance that Phil traveled is the rate that Phil is traveling at times the length of time that Phil has traveled. So I have that Howard's rate, I call that x, and the length of time that he's been traveling is 5. So x times 5, I'm just going to write that as 5x. And over here, that Phil has traveled for the same length of time, but at a faster rate, right? All right, that should do it. That should give us x, which is the distance, but it says find the rates. Yeah. Oh, wait a minute now. Look, I have x being defined as two things here. I need to come in and make a correction here. Sorry about that. I didn't define my variables very well. Maybe you noticed that. I can't have x representing two different things. So how are we going to fix this? Well, instead of using x for a distance, I'm going to use d. So I'm going to say that Howard traveled a distance d, therefore Phil traveled 375 minus d. And that means I'm going to have to call this d, and over here call. So it's a type of mistake that it's good that we noticed it now. It's not going to mess us up that drastically. All right, so rate times time. So the total distance was 375. The distance that Howard traveled, I'm replacing that with the rate that Howard traveled times the length of time, and the same for Phil, the rate that Phil traveled and the length of time that he traveled. So the rate that he is traveling at is x, and the length of time he's traveled is 5. X times 5, I'm going to write that as 5x. And the rate that Phil was traveling twice as fast, so 2x times 5 is 10x. All right, so I think this is going to do it for us, because x will be, it said find the rates. If we know x, then we know Howard's rate. If we double that, then we'll know Phil's rate. So I've got that 375 is equal to 15x, and the x is 375 divided by 15, and what is that? That is 25. So I believe that Howard is traveling 25 miles per hour, and Phil, going twice as fast, is traveling at 50 miles per hour. So how's that? So it turned out that I didn't even use this d and this 375 minus d, but I very well could have. Let's see, how would I have done that? If I had set the two times equal to each other, we said that that's distance divided by rate, but we also know that the total time would be 10 hours. Let's see, distance divided by time. Yeah, I could, since I know the rates. See, not very often in these problems do we know the relationship between the two rates. Since this rate was twice as fast as this, I could have set it up as that I know in my relationship that rate is distance divided by time. And I'm not saying the two rates would be the same, but I could set this rate, this ratio, equal to twice the other ratio and then solve it. So that would be one way that you could do it. I think this way is probably easier. So hey, hope that helps, and I'll talk to you later. Bye.